Hello, this is worksheet 7.5. So we're going to be using elimination in this case. You could use substitution as well to try to solve these systems of equations. However, you're going to realize some goofy things can happen. And so in general, when we try to eliminate the x's, if the y's also are eliminated or vice versa, and we get some number, for example 5 equals 5, which is a true statement. If we get a true statement, the solution is going to be infinite solutions or all real numbers. But if we get some statement like 0 equals 12, which is not true, it means there's going to be no solution. There is no, if we were to graph these lines, there's no place that these lines intersect. So there's no solutions, whereas if we were to graph a situation that looks like this with infinite solutions, it actually means the lines are on top of each other. They're intersecting they're intersecting at every single point the line exists. Alright, so let's do this. So I notice I have opposite x's here, so I'm going to add the equations together because the x's are going to get eliminated, but the y's get eliminated here as well. So on the left side of my equal sign, I have 0 x's or y's. I have nothing, which is the number 0. On the right side, when I add my numbers together, I get 0. Now 0 equals 0. So I can't solve for x, I can't solve for y. It's going to be one of these fancy answers right here. Because I have the left number equaling the right number, it is all real numbers. All real. Ooh, just kidding. It is infinite solutions. I shouldn't say all real numbers. Infinite solutions. Anything that would be a solution on the top equation is also a solution on the bottom equation. Let's try the next one. So I notice that the x's have opposites, so I'm going to start adding the equations together. So the x's are going to get eliminated, and so are the y's. So I get 0 equals, now on the right side it says 10 plus 0, which is 10. Now 0 does not equal 10, so that means there are no solutions. At no time would these lines, if we were to graph them, intersect. If I were to make a table of the values for each of the equations, at no point would there be the exact same coordinate pair on each of their respective tables. If you forget how to create opposites, it'd be good to review some from 7.3. But I need to, actually, just kidding, I have opposites here. I don't need to multiply anything, because the opposite of x is negative x. So I can start adding the equations together. So x plus negative x, again, are opposites. So they make 0x, so they are eliminated. So are the y's. So I have nothing on the left side. When I add negative 15 and 15, I get 0. So I get this truthful statement here, 0 equals 0. That means there's infinite solutions when I have a truthful statement. Infinite, solutions. In number 4, I have opposites, so I'm ready to go. The x's are eliminated, so are the y's. So I get 0 equals negative 4. This is not a truthful statement, so there are no solutions to this system of equations. Wah, wah. Now here, the opposite of negative 9x is 9x. So I need to multiply the bottom by 3 to get opposite x's. And I realize that I don't have opposite y's, by the way. It's going to take work to get opposite y's, so I'm just taking or getting opposite x's. It would be the same amount of work, it seems like. So on the bottom, when you distribute that 3, make sure you distribute it to every single thing, even that 3 over on the right side of the equal sign. So we get 9x minus 24y equals 9. So when I add, the x's are eliminated because I've created opposites. When I created opposite x's, I also created opposite y's. It's a coincidence, it just happened. And so there are no x's or y's. There's nothing on the left side. On the right side, I have 5, so it's no solution. Let's try this one. So the opposite of negative 6x is positive 6x. And I see I don't have opposite y's here either. So I'm going to multiply the bottom by negative 3 because a negative times a negative is a positive. And I want a positive 6x here on the bottom. And I get a positive 3y. And when I distribute the negative 3 to the right side, to the negative 12, I get positive 36. When you multiply by a negative, it makes every single term here the opposite. These are all negatives, so they want the positives. I'm going to bring the top equation over. So I get the x's cancel out here, or are eliminated. So I have 0 x's, so I'm not going to write them down. Now carefully here, if I did my math correctly, the y's are not going to get eliminated, which, so far in this practice, when the x's were eliminated, so were the y's. But yeah, I'm going to double check my math here. Negative 3y times negative y is positive y, so that's correct. And that does not eliminate the y up there. So I get 6y when I add, equals 60. So I can solve for y now. That means that y equals 10. So there is a solution. There is a solution to the system of equations. And I know the y value is 10, so now I substitute that into one of the equations. I'm using the top one to solve for x. That's 30. So I'm going to subtract 30 from each side. So I get negative 6x equals negative 6. So that means that x equals 1. So if I were to graph these two lines, folks, the lines are going to intersect at the coordinate pair 1, 10. Number 7, I'll multiply the top the top equation by 2 to get a positive 2x, which is opposite negative 2x. So I get 2x on top, negative 2y, and negative 22 on the top. I'm going to rewrite the bottom. I didn't need to modify that at all. Notice I have x's that are opposite, so they get eliminated. Ooh, the y's also get eliminated, so I have 0 on the left side of the equal sign. Negative 22 plus 22 is 0, so there are infinite solutions. That's what that says. It's fancy writing. Holy cow, look at that fancy writing. Infinite solutions. Woo! Oh boy, this one looks like a doozy. Look at that, negative 12 and 16. Those aren't opposites. These aren't opposites. I need to create opposites. 48, I think these both go into 48. These both go into 36. So I'm going to create, I know these both go into 36. So I'm going to multiply the top by 4. I'll multiply the bottom by 3. I don't think I have enough, I'll try it. Negative 48x, I'm worried about space here. Positive 36y equals negative 88. On the bottom, 48x, negative 36y, 60. I have opposite x's, although I was actually just trying to get opposite y's, which I did successfully do. The x's are eliminated, the y's are eliminated. I have 0 on the left. I have negative 28 on the right. Those are not equal. It's a false statement, so there are no solutions to this system of equations. Huh, we only have 2 left? Wow, what an easy assignment, Mr. P. Got to create opposites here. 20 is the least common multiple here. 15 is the least common multiple here, so let's get opposite y. So I'm going to multiply the top by 5. Makes negative 20x, positive 15y, 45 on the right. Multiply the bottom by 3. So 15x minus 15y equals negative 30. So I'm going to add them together because I have y's that are opposite. So when I add them, they are eliminated. However, the x's do not get eliminated. And so I have negative 5x equals 15. So that means that x equals negative 3. So there is a solution here, folks. I know that x is negative 3, and then I use that to figure out what y is. I substituted into one of the equations. I chose to use the bottom equation. So we add 15 to each side. We get negative 5y equals 5, so that means y equals negative 1 when we divide by negative 5. So there's our solution. Last but not least common multiple here of 6 and 8 and 6 and 8 is 24. So I'm going to multiply the top by 4 and the bottom by 3. So 24x minus 24y equals 4 times 0 is 0. On the bottom, negative 24x, positive 24y equals 3 times 0 is 0. I have opposites because I can add this together because I have opposite x's, so I get 0x. They're eliminated when I add them together. I also have 0y because those are eliminated when I add them together. So I have 0 on the left. 0 plus 0 is 0. I have a truthful statement here, so there are an infinite number of solutions. I can't list them all, and I'm not going to start. That was fun. Nice job.